Hello friends, so today we're going to discuss a problem set from AtCoder Beginner Contest 123. It's an old problem set but it has 4 questions and we're going to discuss all of the questions one by one. So let's start. The first question is pretty simple. It states that in AtCoder city there are 5 antennas and they're standing in a straight line, and the antennas are named as A, B, C, D, E from west to east, from left to right, and the coordinates of these antennas are given to you in the format like this, and they are increasing. Okay, then 2 antennas can contact or communicate between each other if the distance between them is less than or equal to k, or else they cannot communicate. So you have to find out that whether there exists a pair of antennas in these 5 antennas which cannot contact or cannot communicate. If such antenna pair exists, then you have to output this sad emoji, and if every antenna can communicate, you have to output yeah. So that's the question. It's just a simple brute force way. So you can take the input of all the 5 antennas and then find out the difference between 2 antennas. If the difference is less than equal to k, then it's good. If any one of these antennas is greater than k, then you have to output the sad emoji or yeah. That's a simple. I'll take on to the code part now to even make it more clear. So the code is also very simple. Take the input of 5 because there are 5 antennas. I haven't taken the input of n, but I have just initialized it with 5. Then take the input of all the numbers and also k. Iterate over, this is the total how many antennas cannot communicate. Iterate over 2 for loops because there are only 5 antennas, from I till n and from j is equal to I plus 1 till n. If the absolute difference between the 2 antennas which is stored in this is greater than k, then increment total. And after this, if total is increased, which means that there exists some pair, then you have to output sad emoji or else yeah. So it's a very simple question. Second question is good, in which you have to see how to apply brute force way. So in this question, what you can see here is, so there are 5 types of dishes which you can order at a restaurant, and each dish, as you can see, the first type of dish take a minutes to serve, to make and serve. The second type of dish take b minutes to serve. The third type of dish take c minutes to serve, and so on. Now here, the time to serve a dish, this time which is given to you, is the time between when the order is placed and when the order is delivered. So the whole time to serve is this a minutes and b minutes and so on. Now this restaurant has some following orders. The first thing is, which is the main thing to observe here, is the order can only be placed at a time that is a multiple of 10. If the time is 0, 10, 20, and then only any order can be placed. Okay, only one dish can be ordered at a time. You cannot order multiple dishes simultaneously they are making. You can, at a particular time stamp or on a particular timeline, you can only make one dish. And the last thing is, no new order can be placed when the already ordered is going on. You cannot place new order. Whenever the first dish is started and then is finished, then only the next order can be placed. And the next order should also be placed when there's a time is a multiple of 10. So there's some person which arrived at the hotel at time equals 0. He ordered one dish at time equal to 0, and then he will try all the 5 dishes. Now what is the earliest time in which he can eat all the dishes, all the dishes can be served? So that's the whole question. Now you will see that okay, I can just order all the dishes one by one, but that's the flaw in this question. Why? Because you have to see that I'll open the drawing board, 1 second. Yeah, so the thing in this first thing is, I have to only order the thing in a multiple of 10. Okay, so let's assume that there is one dish which take 9 minutes to complete, and one dish which is 7 minutes to complete. Because though 7 is small, you will have keep in mind that okay, I will first bought 7, the dish which is smaller, because it will take less time to complete. So bring on that dish. But no, because if you bring on that dish 7, then you have to wait till the next multiple of 10, which is 10, and then at that point you will order the next dish, and it will take 9 minutes to complete and serve, so it will take 19. But if you ordered the 9 dish first, then it will be, because you're starting from 0, it will be served till the 9 t equal to 9. Then you have to only wait for 1 second, which is 10, and then you can order the next dish, which is 7, so it will be completed in 17. So you have to take care of these implementations. You cannot just order the dish which is the smallest in time. So now how you can see that which dish is closest to the 10 or not? But the main thing in this question is the constraints. Just see that the constraints are 5 and the length of them is very small. And let's assume that I have 5 constraints. So let's assume that I have 5 dishes to serve. Now the possible number of orders in which I can serve the dishes, I can first order I have 5 options to serve at the starting point. Then like 4 dishes and the next time 3, 2, 1. It's just equal to 5 factorial, which is like equal to 60, which is a very small number. So you can iterate over every possible combination. Like I will first bring the first dish, then the second, third, fourth, then the other order, and so on, more orders. But now if you uses bit manipulation to solve this question, then bit manipulation will tell you to find out the subset. But now in this you are finding different arrangements. Now how you can find a different arrangement? Different arrangements is just like finding permutation. So it's like you have a permutation of 1, 2, 3, 4, 5. You have to find out the possible permutations, which is like 1, 2, 3, 5, 4, 1, 3, 2, 4, 5, and so on. So now how you can find out the permutations of this? And the simplest way is just make another dummy reference, an array like this, which will tell us the order in which I should bring all the dishes. So I have 2 arrays. The first array will tell us the time for each dish to make. Like this is the dish A, B, C, D, and E. And I have numbered another array 1, 2, 3, 4, 5, which will tell us the order in which we should bring on the dishes. Then we will find out all the possible permutations of this string, and correspondingly we can match up these, like the 1, 2, 3, 4, 5. Then we find out the next permutation, and then match up these next permutation to the dishes, and then bring on all those dishes in the order in which we have find out the particular permutation, and then find out the time in which we can serve all the dishes using this given permutation. And then we can find out the minimum among all the following cases, and that's the simplest answer. So you have to see that how to find out the next permutation, and that's a simple inbuilt function to find out the next permutation. I will tell you through this code, because there are again 5 dishes, n equal to 5. It is not inputted, but I have initialized n equal to 5 to make the code look like simpler to understand. Then there is one A and B. A is the time for every dish, and B is the subset or the array we will iterate to make the new permutation. Then we will take the input of all the times, and also bi equal to I, which will initialize the number. What is the order of these dishes? Minimum is the minimum time required to serve all the dishes. We will iterate over all the possible permutations. Then this is a inbuilt function to find out the next permutation for a given array, and then we will keep on iterating over this next permutation till we have iterated over all the possible permutations. Then for the particular permutation, what we'll do, we have stored the particular permutation in this bi. Bi stores the order of the permutation. So we will match out these orders and make another array which is order, and we will push back in order the time for each dish. What does this mean? Which means that, okay, I know that my order is 5, 4, 1, 2, 3, 5, 4, 1, 2, 3, which means that the first dish should be bring at the 5th point, it should be bring at the 5th point. The second dish should become at the 4th time. The third dish should become at the 1st time. So for a third dish, I have to take out the time. What is the time to make the first dish, the second dish, and the third dish according to this given permutation? So I will store out the time of these particular dishes in this order. So how we can do that? We can iterate over all the possible order numbers in this B vector, and for all the possible order numbers we will store that in this order of I. After storing this, we have to find out the total time taken. So how we can find out total time taken? For the first dish, we don't have to wait anything, so we will just add to the total the order of I. But for the next dishes, we have to do a while loop, because at most we have to do 10 steps to find out the next multiple of 10. So we can just easily do a while loop and keep on adding in total till we do not find a next multiple of 10. If it's not the multiple 10, we keep on adding it to the total, and then break out of this loop and then add on the next total. And then we will find out the minimum. This is the total for this particular permutation, and we find out the minimum among all the permutations, and that's the answer. Okay, let's move on to the third question now. Third question is pretty much interesting. I have also asked a modified version of this question in my Sidoc contest, so do check them out if you haven't checked them out. So this question statement states that there is a city, and there are 6 cities, as you can assume, there are like 6 cities, like 1 2 3 4 5 6. Now to travel between these cities, you have to use some convenience. So how many like paths are there? 1 2 3 4 5. Like to travel between one city, there is one path, to another city is one path. So like the total there are 5 paths. To start from this point and to go to the last point, you have to travel like 5 transportations. Now it tells that to travel from city 1 to city 2 in 1 minute through a train, the train, like it will take 1 minute, and the train has the capacity to carry at most A peoples. Then for the same, you can travel from city 2 to 3 via bus, and the bus can carry at most B people. The time will take the same, whatever transport you will take, but the time is same, but the capacity of the mode of transport is different. And you have to see that you have to transport all the people from city A to city 6. Like what is the minimum time you will take? Now you cannot just transport all the people from one city to another city, because you have some particular foundation on the capacity of every mode of communication. So I'll tell you why. Let's assume that my first mode of transport can carry 100 people. Now my next mode of transport can carry 2 people. Then it's like again 100 people, and then it's like 2 people, and then 100 people. Okay, like now let's assume we have 100 people at the start. Then all the 100 people can go from the first point to the second point in 1 minute. Or let's assume you have 200 people here. 100 people go from this, and now 100 people are left at this point, and they have reached here. Now what you can see here is, because the next way of transport is only 2 people can go from this to this at 1 minute. So you cannot transfer all people. You just decrement this by 2, it becomes 98, and the minimum will go to the next point. Now even also this mode of transport can carry 100 people, you just have only 2 people to transport. And now because there is only a vacancy of 2 people, so only 2 people can come from this position till this position, and now it again become 100, and now it has 2 people. So even though the other positions are greater, it can be like 20 also, even the next transportation capacity is maximum, but the minimum among all the capacity will do a constraints over all the following capacities. So what you can see here is, if you find out the minimum among all the following transportations, you can easily get which transportation is actually holding a constraints over all the other transportation. So how does this help us to find out the final answer? See, if you know that 2 people can freely move means if there is only 2 people from this point, it can go from this point till the last point without any foundation. Because if you have like 5 people, then 3 people will have to wait at this point and the other 2 people will go forward. But 3 people have to wait at this point, because you cannot take 5 people through this transportation at once. So even though 5 people can transfer from this to this, but only 2 people can transport from this, and these 2 people will not be hindered by anyone, because the minimum among all of them is 2. So these 2 people can transport among all the way from the starting till the end without any hindrance. Okay, so let's assume that there is some, like it is like a pipe, and if you just input 2 liters, this 2 liter can go directly to the out of this. So, and let's assume that these 2 people will move. Now I have only 2 people, because it's beneficial only. Why it is beneficial? To stand 2 people at this point, because I know that my total capacity is 2. We will just enter them using this constraint only. I will just allow only 2 people to enter from this, 2 people go, because that's the limiting condition for my queue or my like pipeline. And that's the thing. So what you can do in this question is, because whenever the first person entered, it has to take some time to like travel this. So it has to take some time. How much time he has to take? If like 2 persons start from the first point, if only 2 people start from the first point to reach at the end, it will take like 5 minutes, because at every transportation it will take for 1 minute. So in the 5 minutes they will reach and end. But also if there are like 4 people, when the 2 people start moving from this to this point, the another 2 people also starting whenever like they vacant one place, another 2 person can fill up that place. So they are just right behind that 2 persons. So like they are, whenever the first person reach the end, the another persons are just continuously behind them. So it's like a water flow. If the length of the pipeline is 10 meter, you have to first travel the first 10 meter. The first water droplet has to travel the first 10 meters. It will take some time, and then all the rest of the water will keep on flowing out. Okay, so the thing here is we have to add initial distance, like how much total time will take. So if we only care about the 2 people, because 2 people can travel from the first point to the last point. So like let's assume we have 1000 people. So I will divide 1000 by 2 because my constraint is 2, which is equal to 500, which will tell us that okay, if I have all the people traveling just in a queue of series 2, like 2, 2, 2, 2, so they will complete, because like they will complete the whole like this pipeline in like 500 chances. So 500 minutes will take, but because the first person will also have to take 5 more minutes to travel from the start till the end. What does this mean? Because it at every second, like the first second, 1 person, like 2 person are here. The second 2 person are here and 2 persons are again here. Third second, 2 person are here, 2 person are here and 2 persons are here. Fourth, again 2, every one is 2. Fifth, another 2. And at the 6th time, like the first 2 have reached this last state. So this is the first time when some person has reached the last state. And after how much time? After 5 seconds. So you have to add this 5-second buffer, and after this 5 seconds, at every second some or another 2 person will come to the last position because they are in a line. I hope you understand this point. And that's the main trick of this question. You have to divide it by 2 and then add this total number of distances, which is the starting distance, and that's the final question. So let's not have a code part now. So what you'll do, it is input of all the 5, because they are not 5, this is like there are 5 places, not 6, and for the 5 places I have to travel 4 transportations. So take the input of all the 5 transportation places, and then find out the minimum among all of them, because that will apply a constraint limiting condition for all the places to travel. And then find out T1, which is like x divided by minimum. Also, as you can see, if there are like 101 people, then it will be like 500, and then 1 person will be left. In 500 time, like 1000 people have traveled, but 1 person will still remain at the end. So it also have to take 1 more turn. So we have to find out that no person will leave. So if some person are leaving, we have to add 1 more time, 1 more minute to travel that person. So if like some persons are leaving, we have to add T1 plus 1, and then also you have to add T plus 4. T1 plus 4. 4 is actually what I've told you, the buffer value at the start, and that's the whole trick for this question. And then output table. So that's the whole question for the third part. And now move for the fourth question now. Cake 1, 2, 3. So it states that like you are in a pastry shop, and there are 3 types of cake. The cake of shape 1, 2, and 3, and the 1 shape cakes are like there are X1 like 1 shaped cakes. There are Y 2 shaped cakes, and there are like Z 3 shaped cakes. So like as you can see, that there are some cakes of like this 1, 1, 1, 1, and so on, 2, 2, 2, 2. Like this is a 2 shaped cake, 3 and 3. Okay, now every cake of like 1 type, 2 type, like every cake has some deliciousness. Okay, so like you are given some deliciousness for every cake, and now what you'll do, like you have to bought 3 cakes, each of 1 type. Like you have to bought 1 cake of the A, like for the first type. For the first type, 1 type, you have to bought 1 cake among all of them. From the 2 types, you have to bought 1 cake. From the 3 types, you have to bought 1 cake, and you have to bought like 3 cakes in total. And the total number of possible combinations of cake you will bought is equal to, like let's assume you have 3 cakes in the starting line. So you can choose 1 cake from this, you can choose 4 cakes from this, and choose 1 cake from the last. So it is equal to this. This is the total number of cakes, possible number of cakes you can bought if you take 1 cake from the first line, and 1 cake from the second line, and 1 cake from the third line. Fine. But what you'll do here is the deliciousness for the combined means that if you bought 1 triplet of cakes, which is like take this cake, and this cake, the total deliciousness of these 3 cakes is equal to the sum of the deliciousness of the individual cake. Okay, so now what the question statement states here is, among all the possible combinations which you are given, let's assume that you have all the possible combinations, you know the deliciousness of every cake, and you find out all the triplets and find out the deliciousness of all the possible triplets, and you arrange them in a row, which means that if you take a triplet of 1 from the first chain, like first chance, 2 from the second chance, 3rd from the like first chance, from this pair, this is a deliciousness for this triplet, the next triplet, the next triplet, and so on. And if you like sort them out in the ascending order from the smallest or from the largest to the smallest, then you have to print out this actually the sum of the deliciousness, or like the combined triplet deliciousness of the first k cakes. After sorting all the cakes, you have to print out the deliciousness of the first k cakes, and that's the question. Now the thing here is, because x, y and z are all 1000, you cannot do this in O of n cube. Like you cannot find out all the possible triplets and then like sort them and so on. Why? Because x and x, y, z are individually greater than equal to like greater than 1000 at most. So you cannot make a O of n cube solution, but like you can make a O of n square solution. Now how you can do that? You have to see two things. The first thing you have to note that k, which is the total number of cakes we have to find out in the end, is up to 3000. It's small. It's not. It's up to like, it's a range of less 1000. So what you can do here is, I'll tell you how. So because we are in gen only finding out the deliciousness, which is the total summation of all the cakes. So first what you can do here is, okay, take the fourth question. If you just take out the first array and the second array, all the cakes of the one type and all the cakes of the second type, they are at most 10 to the power 6. The total number of like calculations we'll do is 10 to the power 6, which is 10 to the power 3 and 20 to the power 3. So it's fine, you can do this in the given constraints. So find out every possible doublet or like double in which like if we buy these 2 cakes, what is the maximum possible deliciousness we get if we buy just 2 cakes. So what you can do, iterate over every possible 2 cakes, like first cake from the first type and second cake from the first type and so on, and then sort them out. So this will give you a deliciousness in the ascending order if you just take the first 2 cakes clear. Then you have to take out the last 3. So now because you have some numbers which are the maximum number of the 2 arrays, and because you want to add another maximum number such that it will increase its deliciousness, so you will also sort out the third array. Okay, I'm not doing any of O of n cube operation. I'm doing just O of n square or O of n log n. You can separately do these operations, but you cannot do a combined O of n cube solution. You can do separately O of n square, O of n log n and so on. But the total time complexity of the whole question will be O of n square only. Okay, so the next point is, if you sort down the third array, then because this is the largest element, if you take the largest element of the largest among all the tuplets, doubles, then obviously that's the maximum possible cake. Now there can be a case in which you can either take this, which is the second maximum among the total, and the first, which is the third maximum, or you can take the first maximum of the 2 cakes and the second of the last cake. So like there can be many possibilities. So what you can do, then come the final constraint, which is up to 3000. So what you can do, you can iterate over all the possible combinations. First take this and then iterate over all the possible combinations in the last series, because you are taking the maximum element, and then all the elements in the third row, then the second maximum element and all the maximum element in the third, like the third row, third maximum and all the elements in the the third row. So you are actually accumulating all the 3000 elements, because you cannot have some more another elements. You just have to find out the elements in the sorted elements. So you just find out all the possible maximum numbers, you know that these are the maximum number possible, and just store them in some another array, sort them out and just print them out. Why this is giving the correct answer? Because we are finding out the maximum 3000 numbers, but we do not know the order of them. Okay, because if you take this number, which is the maximum among the addition of the two numbers, and if you add it with this maximum number, this is maximum possible. But if you take this number and this number and this number and this number, both of them are like pretty large numbers, but you don't know the order of them, whether this is first or whether this is first. So what the best thing is, put or store all of these numbers in some array and then sort them out. But you can only sort them out if they are like within 1000, 2000, 3000 range. You cannot do this in O of n square or like very large number. So that's the whole trick for this question. You have to analyze the constraints. That's why I've chosen this question also. So let's move on to the code part now. Okay. Yeah. So take the input of all the x, y, z and k, how many numbers you have to output. Then take the input of all the cakes deliciousness of type A, B and C. Sort them out. Then this is AB. We are finding out the deliciousness of the cakes of A and B, taking all the possible doubles. Multiply all the possible doubles, and we are just adding and push them in this A and B. Then we will again sort this whole array of A and B. Then we have to find out the another vector, which is ABC, all the three. So how will you do? You will iterate over the minimum, which is either you iterate over all the possible combinations of x and y or equal to k. You cannot go maximum like above them, even though it can happen that the multiplication of x and y is very less, or they might be very large, but we know that k is up to 3000. So we have to find out the minimum among both of them, and then for every possible case we'll iterate over all the possible z values and push them in this ABC vector. Then again sort them out and just print out the first k values. And that's the answer for the fourth question. I hope you understand the logic as well as the code for all the four questions. If you still haven't watched, mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.